See here, a sphere is inscribed in a cube. A cube is inscribed in a sphere. If a sphere is inscribed in a cube, diameter of the sphere is equals to diagonal of the cube, right? If a cube is inscribed in a sphere, diagonal of the cube is equals to diameter of the sphere. So tell me, it is a two-dimensional figure. You may think it is like a circle and a square. But if you see, actually, it is a two-dimensional figure. Okay, 3D figure, I'm taking it in two-dimensional, right? So tell me, what is the relation? Here, the diameter of the sphere is inside, so I'll take it as a small r. Edge of the cube is a is equals to 2 times of small r, right? Diagonal of the cube, that is root 3a, is equals to 2 times of capital R. You understand the relation between them? Okay, one we are equating it to diagonal is equals to the diameter. Another edge is equals to diameter. Okay, diagonal of a square is root 2a, but diagonal of the cube is root 3a. That is the reason root 3a is equals to the diameter, that is 2r. Okay. In a cube, if you are putting two spheres, suppose. Two spheres of equal volume you're putting in a cube. This is actually equal volumes. Imagine like this. You can just imagine putting a very big balloons in this room in this manner, right? This is the radius. This one is a radius. Now it is a radius, it is a radius, it is a radius and radius. What kind of a figure is this? It appears to be square on the figure. But imagine in this room, it appears to be what? A small cube, right? In that cube, the radius is the diagonal of the cube. Yes or no? So what is the diagonal of the cube when side of the cube is r? Root 3 r. So what is it? Root 3 r. So totally, the diagonal of the cube, that is root 3 times of a, is equals to 2 times of radius plus root 3r. So a by r is equals to 2 into root 3 plus 1 by what? Root 3. By r is equals to 3 plus root 3 by what? By 3. Okay, this is the relation between cube when two cubes are inscribed in a, when two spheres are inscribed in a cube. You can go with three, okay, 3 spheres also. The same logic, okay? You can derive it for yourself then. Suppose if a cube is inscribed in a cone, can you tell me how it looks like? It looks like a square is inscribed in a triangle. Yes or no? You know that this is a, if I take it as b, which is equals to 2 into r, you know this is h remains h only. You remember side of a square is equals to bh by b plus h. Here also same logic can be applied. A is equals to what? bh by b plus h. bh by b plus h. Is that clear? So bh by b plus h, what is b? Where b is equals to what? 2 times of radius. How bh by b plus h? You can equate the area of triangle plus area of trapezium to the area of the triangle. If you equate, you will get the same formula. It will be the same. Suppose if a sphere is inscribed in a cone, If I take a sphere inscribed in a cone, it is 90 degrees. It is 90 degrees. Common angle. Common angle, you can take it as theta. If it is phi, this is also phi, isn't it? Can I say so? Can you tell me what is the height of the cone? Is h, right? I'll take the radius of cone is small r. Radius of sphere is capital R. Is it clear? What about this? Can I take it as h minus r? As r no? Can you tell me what is sine theta from this? What is sine theta in the smaller triangle and what is sine theta in the bigger triangle? You can see the similarity there. I would say sine theta is equals to, opposite is capital R, hypotenuse is h minus small r. Opposite is okay. Better we take. Should we take tan theta? This is capital R is okay. And this one is L, right? Yep. This one is radius. Yeah, it's capital R, not smaller. It is radius, though. I can say this is also a radius. Capital R is the radius of the sphere. Okay, this is capital R, radius of the sphere. This one is also radius of the sphere. We are taking it as capital R. Now look at small r. Small r is the radius of the cone. Small h is the height of the cone. Small l is the slant height of the cone. Okay. And in this triangle, I am using sine theta. Sine theta is opposite by what? By hypotenuse. Now look at sine theta in this. It is opposite by hypotenuse. Now you equate opposite by hypotenuse. From this you can derive capital R is equals to what? HR by L plus R. What is H? Height of cone. What is L? Slant height of cone. What is R? Radius of all of cone. Okay, it is HR by L plus R. If a cylinder is inscribed in another cylinder, imagine like this. Looks like this. Look at the top view. You'll get the top view like this. Yes or no? This one is height of the cylinder, I would say. This is the height of the cylinder. This is the diameter of the cylinder. Diameter of the larger cylinder. If you look at the top view, then you can say h square plus 4r square. 4 into capital R square. How do we find out the radius? This is how we find out the radius. This is cylinder, one cylinder inscribed in the other cylinder. This is H, it's 2R. This one is 2 times of capital R. Copy them. The surface area of the cube is 726 square centimeters. Find the volume of the cube. The volume of the cube is equals to a cube. Surface area of the cube is given, right? We take 6a square is equals to 726. A square is equals to 121. A is equals to 11. Now substitute in this 11 cube 1331. Surface area of a cube is 6a square, which is equals to 726. A square is 121. Therefore, A is equals to 11. A cube is 1331. Find the length of the longest pole that can be put in a room of 10 meters long, 9 meters broad, and 7 meters high. Under root of L square plus B square plus H square. L square is 10 square, 9 square, 7 square. How much it is? Root of 230. The whole surface area of a rectangular block is 8788 square centimeters. If the length, breadth, and height are in the ratio 4:3:2, find out the length. Length is equals to 4x, breadth is equals to 3x, height is equals to 2x. Whole surface area means 2 into LB plus BH plus HL. Right? 4 3s are 12, 12 2s are, sorry, 12, 12 plus 6 is 18, 18 plus 8 is 26. Every time you'll get into x square, x square, x square. So 4 3 is 12 plus 6 plus 8. So it is 26. Here 2, here 2. If you cut it in 4 table, 4 2s are, 4 1s are, 4 9s are, 4 7s are. Okay. You must remember this 2197 is actually a cube of 13. Even if you multiply it, if you divide it with 13, you get 169. So x is equals to how much? 13. So if x is equals to 13, what is he asking? He's asking find the length. Length is equals to 4x. 4 times of 13 is equals to 52 centimeters. Right? In a swimming pool measuring 90 meters by 40 meters, 150 men take a dip. If the average displacement of water by a man is 8 meter cube, what will be the rise in the water level? Assume that this is a swimming pool. Let's say we have water up to here initially. Now, how many members took a dip? 150 members took a deal. It's not getting. It's a pen problem. You can imagine. All right. That's a pen problem. They're not working properly. Fine. Try to imagine in this. So water level will come up. So water level will come off if 150 members take a dip. Each member displaces how much water? 8 meter cube. So 150 members displaces how much water? 150 into 8. This water displaced is equals to the level increased, the volume increased in the swimming pool. We know the length and breadth, but we don't know the height. So let's take height, everything it in terms of meters. So h is equals to what? 150 into 8 divided by 90 into 40. You can simply say 1s up, 5s up, 30s up. I would say it is 1/3 of what? Meter. But convert it into centimeters, it is 33.33 centimeters. Is that clear? I'm converting it into centimeters. So how much water increases? Water level increases by 33.33 centimeters in the swimming pool. Right? Copy them. Right, but controls are not working. Is the bad, I guess. is working. So we start చేయాల్సిందే. స్టార్ట్ కూడా కాలేదా? Just a second, I'll restart the computer.